So, have you ever stopped to wonder how a computer or an AI actually thinks its way through a problem? I'm not talking about just crunching numbers, but really solving a puzzle, finding a route or making some kind of strategic decision. Okay, let's dive into this because the answer is surprisingly elegant. Here's the basic question, right? When you're faced with just a massive number of possibilities, how does an AI find the single best solution without just getting lost? How does it navigate that maze of choices? Let's make this super simple. Just picture this Pac-Man maze. The whole goal is to get from the start to that dot on the other side using the shortest path you can find. Now, you and I, we can see the whole board, right? But for a computer, it's just a series of choices. Left, right, up, down at every single junction. So where in the world does it even start? So how would a computer start? Well, the most basic way is something we can call the blindfolded search. And it's pretty much exactly what it sounds like. And it's the perfect way to understand why we desperately need a smarter approach. The idea here is painfully simple. You just start exploring. You go down one path till you hit a dead end, then you backtrack and you try another one, then another and another. You're just systematically checking every single possible route until, finally, eventually, you just happen to stumble upon the goal. In computer science, this has a name. It's called uninformed search, and this image just nails it, doesn't it? The algorithm has absolutely zero clues about where the goal might be. It just explores, digging in every direction, kind of hoping to get lucky. It'll get there, for sure, but it is not smart. So, here's the bottom line. The huge problem with being uninformed is just how inefficient it is. Because it has no idea if it's getting warmer or colder, it wastes a massive amount of time and energy exploring paths that are obviously leading way away from the solution. For any puzzle more complex than a simple maze, it's not going to work. Okay, but this is where it all gets really interesting. If the blindfolded method is basically broken, what's the fix? Well, it's simple. You give the search algorithm a compass. What if, at every single junction, the algorithm had a hint, a little nudge telling it, hey, that way looks a bit more promising, or, yeah, you're getting warmer. This one simple idea is really what separates brute force from what we think of as artificial intelligence. And that hint, that rule of thumb, has a name. It's called a heuristic. Now, it's not a perfect calculation or anything, it's really just an educated guess. So for our maze, a really simple heuristic might be the straight line distance to the goal. It's not the actual path distance, of course, but it's a fantastic clue. So a heuristic is basically like a getting warmer meter. At every choice point, every move the AI is thinking about gets a score, an estimate of how good that move probably is. The AI can then prioritize the paths that are moving the needle closer to that goal. And that's really it. Algorithms that use a heuristic are called informed search. They're not blind anymore. They have a guide, this little heuristotron that helps them make intelligent choices, focusing all their effort on paths that are actually likely to lead to a solution. Smarter, not harder. But even with a compass, there are different ways to travel. And it turns out, there are different personalities for these informed search algorithms. Let's take a look at two of them. So on one hand, you have what's called greedy search. This one's the impulsive one. It only looks at the heuristic, what we call h of n, that estimated cost to the goal. It always jumps to the next step that seems to be the closest to the finish line, and it doesn't care at all about the journey it took to get there. But then you have A-star search, and A-star is more balanced. It considers two things, not just the future estimate, h of n, but also the past, the actual cost it took to get to this point, which we call g of n. So it's always balancing the journey so far with the estimated journey still ahead. So why does that balance matter so much? Well, the danger with a purely greedy approach is that it gets fooled easily. A path might look like a great shortcut at first, but it could lead you right off a cliff or into a dead end that's technically close to the goal as the crow flies, but is completely impossible to reach. A-star avoids all that by caring about the entire path. Now, this isn't just about video games or mazes. These kinds of search problems are absolutely fundamental to things like logistics, network routing, and all sorts of complex optimizations. And some of them are so classic, they've attracted some very famous problem solvers over the years. And this leads to some pretty fascinating computer science history. Believe it or not, one of the key academic papers on a famous search puzzle called the pancake sorting problem, which is literally all about how to sort a stack of pancakes in the fewest number of flips, was co-authored way back in 1978 by none other than a young Bill Gates. So, as we start to wrap this up, let's bring it all back to the one single most important idea that makes this whole thing work. Here's the main takeaway. What makes an AI search smart isn't just about having a faster computer that can try more dead ends more quickly. No way. The real secret is having a good guide, a good heuristic that points it in the right direction from the very beginning. At the end of the day, it's the quality of that educated guess that matters most. A really clever heuristic can slash the search space from billions of possibilities down to just a handful. It transforms a clumsy, blind search into something that feels, well, truly intelligent. And that leaves us with one final thought. We use heuristics all the time in our own lives. When you're deciding which route to take to work, you probably have a rule of thumb like avoid the highway during rush hour. So think about it. What are the clever and maybe sometimes flawed heuristics you use to navigate the complex puzzles of your own life?